Okay, here we go. We are going to find the derivative of the square root of x. Well, we're going to do the same process we did on the others. So let's start by finding f of x plus h, which is really the square root of x plus h. And there's no simplifying we can do there. There we go. That's it. It's going to get sloppy over here, but not over here. By the way, when we're done, also, of course, there's an extra part to this question. State all the x values where the line tangent to the graph of f of x has a slope of 1/10. What? Okay. Deal with it later. Let's find the derivative first. We have to find the derivative before we can do that. So here we go. Sorry, maniacal laughter. I couldn't help it. This is going to be great. You're going to love it. Trust me. Said the evil mathematician. X plus h minus square root of x all over h. Okay, this is what we have. And we've done problems like this. We have. When you have a square root, you can do what we call multiplying by the conjugate over itself. You're multiplying by 1. You've seen this before, okay? So bear with me. I know you're looking at this saying, where my numbers go, I have x's and h's, but the only number I see is the forbidden 0. I hear you. Trust me. We're dealing with concepts, not concrete things at the moment. So we are going to multiply by, okay, by what? I'm glad you asked. The square root of x plus h plus the square root of x. Okay, we've seen this before. That was subtraction, now it's plus, and that's going to cause the outer and inner to cancel when we multiply them together. And then we will do the same thing in the denominator, x plus h, and square root of x, there we go. So let's proceed. We have the limit as h approaches 0 of, let's do the denominator first, I just find it easier. H and then square root of x plus h plus square root of x. Don't distribute, complicates your life. Don't make your life any more complicated than it has to be, right? When you multiply out the numerator, you would essentially FOIL it, but again, the outer and inner would cancel because we would have positive stuff and negative same stuff, and they would just cancel out. So we're left with square root of x plus h times square root of x plus h, which is x plus h, right? Right. Okay? Square root of x times square root of x, which is just x, but we do have different signs on those, so it's subtraction. And we'll bring this over here. We see the x minus the x, and we have the limit. As h approaches 0, well, the x and the x cancel, and I have h over h, and then all that stuff in the denominator in parentheses there, square root of x plus h plus square root of x. I might be off the screen, am I? No, I'm not. Still have plenty of room. Sloppy, but I have plenty of room. Okay, I hope you notice that these h's cancel and I have 1. Let's keep going. So I really have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. And I look at that and say, well, I'm going to just plug in a 0 now if I can. Can I? Yes, I can. If I plug the 0 in right here, I would have the square root of x plus 0, which is the square root of x, right? So I would have 1 over the square root of x plus the square root of x. And what I really have is a squeaky marker. I don't know if the microphone's picking it up or not, but it's like really annoying. Anyway, square root of x plus the square root of x, which is going to give me not the square root of x squared, but 2 times the square root of x. I have 1 of them and another 1 of them, so I have 2 of them. So I have 1 over 2 square root of x. So my final answer, other than the sentence that we'll deal with in a minute, is that the derivative of the square root of x, the slope at any point on the square root of x, it is in its domain, in its differentiable domain, is, which would not include 0, is this, okay? All right, now let's tackle the actual question that we had to have this for. State all x values. Okay, final answer will be x equals blah, 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 okay? Where the line tangent to the graph, okay, if I have a tangent line, then the line that is tangent to a graph represents the slope at a specific point, right? So this is the graph of the square root of x, and then the line tangent to that would be just some line like that. It would have the slope represented at that specific point of tangency. It was a bad representation, but there we go. Final answer will be x values. I'm dealing with slope. That's what I found. Derivative is slope. Has a slope of 1/10. Oh, well then, I need this to equal 1/10. I need to know every place, every x value that this is equal to 1/10, because that is the slope. So let's do it. 1 over 2 squared root of x equals 1/10. And we're just going to set the derivative equal to the slope that we want. The slope I want is 1/10. Take the derivative, set it equal to 1/10. We'll cross multiply. That gives me 2 squared root of x equals 10. That gives me the square root of x equals 5. I will square both sides and I will have 25 done. That's it. We answered the question. That's all we had to do.